Hello students, today in this video we are going to do a numerical based on Kirchhoff's law. In the previous video we learnt about the two parts of this law, junction rule. What is the junction rule? Sum of the currents entering a junction is equal to the sum of the current leaving a junction, or the algebraic sum of the currents at a particular junction in a network is 0. The second rule is the loop rule or a mesh rule, which says that the changes in potential in a network in a particular loop is 0. The first one, junction rule, is based on law of conservation of charge, and second rule is based on law of conservation of energy. Because whenever we talk about EMF or we talk about the potential difference, it is nothing but work done on a charge and nothing but the energy. I have taken a numerical here, a simple numerical. It has got two cells are there, 4 volt and this is 6 volt. There are 3 resistors are there, 2 ohm, 4 ohm and 12 ohm. Now let me mark the points here, A, B, C, D, E, F. Okay, now I have marked these points here. The current is coming from the 4 volt cell. It starts from positive. Let me say the current is I1. And the current from the 6 volt, let us call this as I2. We know that the I1 is going out, so the I1 should come back. And the I2 is coming out, so the I2 should go back. Okay, this much we know, right? Now, you see here the junction is B. I1 is coming and I2, you see I1 is coming and I2 is coming. They come together and let us say the current is I3. What does the junction rule says at this point? The I3 is equal to I1 plus I2. This is the one of the fundamental or basic equation, right? And we are going to use this now. So now we will use the loop rule and find the loops. Okay, now always I do in one way, that is I start from positive, right? I start from positive, A, B, E, F, A. Again I repeat, I have taken a loop like this starting from A. So for the loop A, B, E, F, A. For this loop, what are all the changes in potential? Fine. So let us see, from positive I am taking here, right? I3 and this is going through 4 ohm. So that is 4 I3. You understand? Change in potential, 4 I3. Then it comes slowly like this. I1 is coming, but I1 is going through the second 2 ohm resistor. So we know that Ohm's law says V is equal to R into I. R is 2, current is I1. So plus 2 I1 is equal to. How the current started? It started because of 4 volt battery, the EMF, right? That is equal to 4. Fine. Look here, 4 to 4. I divide throughout by 2. I get an equation 2I3 plus I1 is equal to 2. It is very good that we substitute from this equation number 1 for I3. So you get 2 into I1 plus I2 plus I1 is equal to 2. I made the substitution now, right? Let me open the bracket. 2I1 plus 2I2 plus I1 is equal to 2. 2I1 plus I1, that is 3I1 plus 2I2 is equal to 2. Right? See, 3I1 plus 2I2 is equal to 2. Call this as equation number 2. I hope you understand now. I have taken one loop and that loop I have calculated the changes in potential and I have derived an equation. Let me write this equation here. 3I1 plus 2I2 is equal to 2, equation number 2. Right, first loop is over. Now we are going to form a pair of linear equation. In a pair of linear equation with the two variables, I1 and I2 are two variables like x and y. I need to solve this and I have to eliminate it. Okay, how can that be done? For that, let me first erase this loop is over. Now let me go to the second loop. So what is the second loop I am going to take now? Let us see carefully. See, again I said I always start from positive. So terminal close to that is C, C, B, E, D, C. C, B, E, D, C. Close it. You start from A, close it at A. Start from C, close it at C. That means the closed loop. The closed loop I have taken is somewhat like this. C, B, E, D, C. I hope you understand now. Now we will find out as usual what are all the changes in potential. Changes in potential. I2, I2, I2. Here is I3, 4, I3, 4, I3 plus. Again I2. The same I2 is coming at this point. The resistance is 12 using Ohm's law. 12 I2 plus 12 I2 is equal to what is making the change? The 6 volt battery. So the EMF is 6 volt. So 6. You see again here even number. I hope I can divide it by 2. So 2 I3 plus 6 I2 is equal to 6 by 2, that is 3. Using the first equation, let me substitute for that. 2 into I1 plus I2 plus 6 I2 is equal to 3. Okay, that is, open the bracket, 2 I1 plus 2 I2 plus 6 I2 is equal to 3. Right, I2 is common, right? 2 I1 plus 6 I2 is equal to 3. Right? 1 minute, 6 plus 2, that is 8. 8 I2 is equal to 3. Call this as equation number 3. I hope you understand now. Check it one time very carefully. Have we formed the equations correctly? That you have to check it. Because if you make a mistake in the forming of the equation, then the answer ultimately will come wrong. Okay, now I have got this much now. So 2 I1 plus 8 I2 is equal to 3. This is third equation. Now it's very simple for me. I have to solve these two equations. Fine. Now we got these two equations. Okay. I hope you can see from here also. Let me eliminate I1. In order to eliminate I1, what should I do? I should multiply this by the coefficient 2. I should multiply this by coefficient 3. 3 here, 2 there. So we get an equation 6I1 plus 4I2 is equal to 4. Equation number, first equation. Right, second one, 3 2s are 6. So 6I1 plus 8 3s are 24 I2 is equal to 3 3s are 9. Okay. Now you see the coefficient of I1 terms are same. So change elimination method. Plus becomes negative. Negative becomes positive. Right. So 6I1 minus 6I1 gets cancelled. 4 minus 24, that is 20 I2 negative sign. That is equal to 9 and 4, 5 is equal to 5, again negative sign, minus. So minus minus gets cancelled and you get I2 is equal to 5 upon 20, that is nothing but 1 upon 4. So I2 is equal to 1 upon 4 ampere. Ampere is that of the unit of the current. So 1 upon 4 ampere. It's very simple. Take the first equation, 3I1 plus I2 is 1 upon 4. So 2 into 1 upon 4 is equal to 2. So 2 gets cancelled. So 3I1 is equal to 3I1 plus 1 upon 2 is equal to 2, or 3I1 is equal to 2 minus half, that is 1 and half, that is 3 by 2, or I1 is equal to 3 divided by 2 multiply by 3 goes here, 1 upon 3, 3 goes, so you get half. So you get I1 is equal to half ampere. We have got I2 is equal to quarter ampere, right? And I1 is equal to half ampere. This is what the values we have derived at. Now, it's very simple. Once you have reached till this, it's very simple. I1 value we got how much? Half, that is 0.5 ampere. Okay, I2 we calculated 1 upon 4, 0.25 ampere. So if you add these two, 0.75 ampere is passing through I3. So that is how did I do that? That is nothing but 1 upon 2 plus 1 upon 4, that is 3 upon 4. So I3 is equal to 3 upon 4 ampere. Okay, it looks very complex. I am telling you, it is not complex. Only when you know where to take, how to form the loop. I follow only one thumb rule for me. Yes, I start from positive, I go from positive. Different teachers will do in different ways, right? My approach is I start from positive and come back to negative, and so that I go in one particular direction, conventional current direction. Other methods also are there, right? But this is a method which I follow, and I hope you also do some more numericals. Practice will make you perfect, and thank you so much.